Whenever we talk about AI agents writing code, it's always this mix of, wow, this is amazing, and oh no, this is going to be chaos, right? So, what if you could get all that power, but without the pandemonium? Well, that's exactly what we're diving into today. We're looking at a system called the M4 NDAC Autonomous Agent Control Plane. And honestly, it's less of a tool and more like a digital constitution. It's a set of hard and fast laws for this new digital workforce. So, let's get into it. So this quote, it really hits home, doesn't it? Technical bankruptcy. That's the crisis so many organizations are drowning in. And look, autonomous agents, they aren't just some cool new toy. They're being positioned as the potential answer to this mess. The big promise is this digital workforce that can just chew through the mountains of technical debt holding everybody back. But, and this is a big but, to actually get there, we've got to move way beyond just having a simple AI copilot. We need something with real discipline. All right. So here's the plan for today. First, we'll tackle the crisis of autonomy. Then we'll get into the M4 NDAC control plane itself and its mandates and hard stops. After that, we'll meet the digital workforce, check out the principled system design they have to follow, and wrap up with how the protocol gets debugged. Let's jump in. Okay, first up, the crisis of autonomy. Because, before we can really get our heads around the solution, we have to understand the problem. And the problem is, when you just unleash a bunch of powerful AI agents on your code with no rules, you don't get innovation. You get absolute chaos. You get something called agentic sprawl. So what is agentic sprawl? Think of it as the digital Wild West. It's what happens when you have, say, two different AI agents tripping over each other, trying to refactor the same piece of code at the same time. Or maybe you've got a zombie agent just burning cycles on a task that nobody cares about anymore. It's a mess. And the real kicker? Without a central government, the very agents that are supposed to fix your technical debt end up making it even worse. All right, let's talk about the solution, the M4 End8 control plane. So how do you fight all that chaos? Well, the M4 End8 protocol has an answer, and it's all about having a single, powerful source of truth. And that truth lives in a file called director.yaml. Now, this isn't just some config file you set and forget. No. This thing is the central nervous system for the whole show. And when I say it's the nervous system, I mean it has absolute authority. The protocol is super explicit about this. Director.yaml is the commanding officer, period. Every single agent, every process, it has to check in with this file. It defines the rules of engagement, the budget for changes, even the very order in which the AI agents are allowed to perceive reality. It's the boss. And that authority is enforced through a really strict, non-negotiable read order. The system doesn't just randomly grab info. It builds its understanding of the world very methodically, step by step. First, it reads the rules from director.yaml, then the runtime truth from manifest.yaml, then the code's wiring diagram from hub.md, the shared ledger, and so on down the line. There's zero room for ambiguity. This whole rigid sequence is designed to stop agents from flying blind and acting on half-baked information. Now, this is one of the most important rules that comes from Director YAML. It's this idea of a sovereign blackboard. Here's the deal. Agents are absolutely forbidden from passing notes to each other through chat history. Why? Because chat is messy. Things get lost, context gets dropped. It's like a game of telephone. So instead, everything, every single finding or change has to be written to a shared public ledger, this kafo.md file. It's a classic design pattern, the blackboard, and it guarantees that every agent is working from the exact same, complete, and up-to-date picture of reality. Okay, next up, mandates and hard stops. Let's look at the actual laws that give this whole protocol its teeth. And just to be clear, these are not suggestions. They are hard-coded rules designed to enforce discipline and keep the agents behaving predictably and safely. Break any of these rules and boom, the entire system comes to an immediate halt. It just stops dead. And look how specific these are. An agent can't just go off and invent a new feature that wasn't in the original spec. It can't create a file that wasn't already planned for in the hub.md wiring diagram. And maybe the most important one, if an agent gets confused or sees something ambiguous, it's not allowed to guess. Its only legal move is to stop and ask a human for clarification. No winging it. All right, so we've talked about the rules of the game. Now let's meet the players, the digital workforce. See, the M4 End8 protocol doesn't believe in some single, all-powerful super agent that does everything. Instead, it builds a team of specialists. Each agent has one very specific job, a lot like a real-world software team. And this is the team. It's all about specialization. You've got your architect, who's like the project lead turning the spec into a concrete plan.
Then the builder comes in and just follows that plan to write the code. The tester is your QA, making sure it all works. You even have a sentinel, who's basically a cop on the beat, making sure everyone's following the rules from director.yaml in real time. And super importantly, you've got a janitor.
Okay, let's focus on this janitor for a second. Remember that whole agentic sprawl problem we started with, the chaos and the mess? Well, the janitor is the system's direct answer to that problem. Its entire job, its whole reason for being, is to clean up after the other agents and make sure things stay tidy. So what does it actually do? Well, its duties are pretty straightforward, but they are absolutely critical. It's basically a code hygienist. It follows the builder around and it cleans up stuff like unused variables or commented out code. It makes sure everything follows the right style guides, and it gets rid of any temp files that aren't supposed to be in the final product. It's constantly fighting against entropy and actively keeping that technical debt from piling up. Moving on to principled system design. Because this system, it's not just a bunch of random rules and a list of jobs. It's really about enforcing proven high-level engineering philosophies on the agents themselves. It's about baking industry best practices right into the AI's core workflow. And one of the best examples of this is the mandate for Agentic Test-Driven Development, or TDD. The protocol forces the agent to write a test case first, and critically, that test has to fail. Only then is it allowed to write the code to make the test pass. Why? Because this is a powerful anti-hallucination tool. That failing test gives the AI concrete real-world feedback. It grounds the agent and says, this is what success looks like, don't do anything else. It's brilliant, really. The protocol also forces the agents to be good architects. For example, when two different parts of the system need to talk to each other, the architect agent has to make a conscious choice. It's a classic trade-off. Do you want blinding speed, we're talking nanoseconds, but risk a single crash taking down the whole system? Okay, that's an in-process extension. Or do you want safety and isolation, where a crash in one part doesn't affect anything else, but you accept a little more latency? That's a subprocess. The protocol actually steers the agent towards the safer, more robust default, which is a really smart design choice. Okay, last section, debugging the protocol. So what happens when a rule gets broken? I mean, a system this strict is going to fail sometimes. The key is that it's designed to fail safely, and maybe more importantly, to fail informatively. It's not good enough for it to just stop. It has to tell the human operator exactly what went wrong and why. And this is what that informative failure looks like. When a hard stop happens, the system doesn't just throw a random error. It generates this clean, structured, machine-readable alert. The HALT protocol tells you everything: which agent messed up, what rule it broke, and it even gives you a citation pointing to the exact file and the specific line or clause that was missing. It's basically a perfect audit trail for every failure. So you might be thinking, wow, this is a lot of trouble. Why enforce all this rigid structure? Well, because without it, you get answers that look right but are actually dangerously wrong. And that brings us to this number, 63.75%. So what does that number mean? Well, a deep analysis of the SW Bench benchmark, a really common way to test these things, found that almost 2/3 of the AI-generated fixes that passed the tests were suspicious. They made the test go green, sure, but they didn't actually fix the root problem. Sometimes they just worked around a weak test. And this is a huge deal. It proves that just passing tests is not enough. It is not a reliable sign that the code is correct. And that right there is the ultimate argument for why you need these strict protocols that demand verification, traceability, and real discipline. And that kind of brings us full circle. We've been talking about these systems as digital constitutions for governing AI, but they also have huge implications for the humans, right? For the developers working alongside them. So as we build these incredibly structured systems, we have to ask ourselves, what essential rights do we need to guarantee for our human developers? You know, rights to things like clarity, the ability to easily debug what the AI is doing, and ultimately, the right to have the final say. It's a big question to think about.